All right, chapter 10, we have a couple more graphing problems. These are a little different with square roots, and so when we're looking at these, we really think it's really helpful to recognize you can talk about domain and range really easy. Okay, the domain in these is different. For domain here, one of the things you have to pay attention to is a square root can never have a negative in it. Okay, this is bad. Square root of any negative is bad. And so what we know is that the dividing line between positive and negative is 0. Okay, so what you have to do is ask yourself, what is going to make x, or the value that's inside of here, in this case x, what's it going to make it greater than or equal to 0? In this case, there's your answer. You don't have to do any math, right? We'll take a look at another one in a second. I can't get negative values. That means there's going to be nothing on this side of my graph here. Okay, we need to do another one really quick to show you. This one has a -1. So I would ask myself, what value for x is going to make this greater than or equal to 0? Well, I would just add 1 to both sides. And there would be my domain. My domain is that x has to be greater than or equal to 1. Now, you don't have to solve it this way every time. Basically, when you're looking at this, if it's a simple one like we're seeing here, just tell me the opposite of whatever this number is. If it's -1, it ends a +1. If it's no addition or subtraction, it's just a 0. And they could get bigger like this one, so it would be +2 because it's a -2, so the opposite of that. Okay. The range, also kind of simply, y is going to be greater than or equal to, this number tells you your value. Okay, the lowest it's going to be, because the lowest this can be is 0, the lowest y will be is 3. All right? So you get your range really simply. Again, I can look at this one. Range, y is greater than or equal to 1. Okay? Just to show you again on this one, they didn't ask us for these, but this is a little tricky. I have to move my 12 over here, but this would be like -14. Move this guy over here, that would be -1. So you have some of those values. It's you're looking at the number outside of the square root for the range. Okay. And the rest of the time, since they're asking me to graph, I just make a little table and I start to plug in values. Now, thinking about something like this, I'm going to pick numbers that I know work really well. I'm going to think of numbers that are perfect squares. So if I plug in 0, I get 3. Right? If I plug in 1, I get 4. I wouldn't want to plug in 2 here because the square root of 2 is an ugly decimal. So I'm going to jump to 4. The square root of 4 is 2. 2 plus 3 is 5. And I'll do one more. 9. Jump up to 9. The square root of 9 is 3. 3 plus 3 is 6. So if I started to graph these, get an idea of where this is. Starts here. Goes up to here. And then the next one I did was 4, so over 4, up 5. 1, 2, 3, 4, 5. And then over 6, 9. 4, 5, 6, 7, 8, 9. Up 1, 2, 3, 4, 5, 6. So we've got the shape like this. So then we go on forever this way. As long as x is greater than 0, y will be greater than 3. So it's going to go over this way forever and kind of like really slowly because it's going to come out really far, but it never stops going up. It goes up forever. Okay, so this one very similar. I already have the domain range. All I need is my graph. X and y. If y is, I'm going to start with my lowest value I can for x, so 1. If x is 1, this whole thing becomes 0. 0 plus 1 is 1. So over 1 is 1. Start right there. If I plug in 2, notice 2 does work here. 2 minus 1 equals 1. The square root of 1 is 1. 1 plus 1 is 2. All right? The next one, again, if you're picking your perfect squares, and again, I have to get a perfect square within the square root. So I'm going to pick a 5 here. Watch what happens. 5 minus 1 is 4. Square root of 4 is 2. 2 plus 1 is 3. If you're picking your numbers that are going to give you perfect squares here, these are just going to increase by 1. So 5, 1, 2, 3, 4, 5, up 1, 2, 3. So if I got my next perfect square, it's going to be 10. This value will end up being 4, which is really nice. Okay, so 10 and 4. And my graph will look like this. All right. All these other ones they're asking us to solve. So what you do basically is isolate your square root by getting it by itself, right? Isolate means get it by itself. So we're going to add the 2 to both sides, and you have the square root of x equals 14. And then to solve this, I just square both sides. Not square root, but I square both sides. You get 196. Okay? On this one, you're going to do the same thing. I'm going to subtract 4. Equals 1. And I'm going to square both sides. X minus 2 equals 1. And then I add 2. So this one has an extra step. You have to add that 2 at the end to get your answer. What's nice is, again, on all of these, you could check your solution. If I plug 3 back in, 3 minus 2 is 1. The square root of 1 is 1. 1 plus 4 is 5. You can check all of the work. Again, this one, very similar. It just looks slightly different. So I'm just trying to show you a couple of different looks on these. Okay, negative 3, the square root of x equals negative 10. All right, I'm going to divide by negative 3 first. And you have the square root of x equals this not really nice number, but 10 over 3. All right, it's negative divided by negative, and so when I square it, I end up with x equals 100 over 9. That would be my answer. Now, one quick caution, if I'm throwing this out there, if I'm looking at a problem like this is completely aside, I'm just making this up. Let's say I ended up with something like this, similar problem, but I'll change it a little bit. Let's say I had, I'll make it a little nicer, 5 plus 2, the square root of x equals, we'll say negative 3. Okay, so I would subtract 5 from both sides, divide by 2, I get the square root of x equals negative 4. I want you guys to see this, okay, and recognize that it's okay to have a negative here, because this next step I'm going to square. What I would want you to be careful of is that when I punch this guy in on my calculator, it's negative 4 squared, which equals 16. Okay? Alright? Now, notice, problem. If I take 16 and I plug it in, square root of 16 is, just want us to see the problem here. Alright? Negative 16 here. 5 plus 2 times 16. So square root of 16 is 4, 2 times 4 is 8. Do I get negative 3? No. Okay. So notice this. What happens is I have a problem. When I try to solve this, I'm never going to get a negative. Okay. When you have a square root equal to a negative, I could do the math, and the math kind of looks like it's working, but I'm recognizing I'm never going to get like a negative out of a square root in that sense. Okay. And so we have some issues that we run into if it ends up equaling, not like this one I divided by a negative, so it worked, but when I divided by a positive, this stayed negative, and I ran into some issues. Again, the math, like I said earlier when I was on the step, I said it's okay because the math is going to work, but when I plug it back in, you'll see that like the answer doesn't actually give you what you expected it to give you. So checking your answer on these is really helpful. You would want to look out for that on a multiple choice test. You know, if it says like there's actually no solution that's going to make this work, instead of like doing the math, and you'll get x equals 16, and that might be one of the options. So just pay attention to those things. All right. This one is very similar. Again, I'm just trying to show you there were a bunch of problems like this where they asked you about perimeter or something like this. So for perimeter, it's like doing this. If I add up all the sides, I should get 26. So I know this looks really weird or maybe a little complicated, but I have 2 of these. So this is 2, the square root of x plus 5 plus 18, 9 plus 9 equals 26. So I'm going to subtract my 18 first. So you got 2, the square root of x plus 5, all right, equals, we have a total of 8 there. I'm going to divide by 2, divide by 2. Try to get that to scroll down a little bit. So you have x plus 5 inside of the square root equals 4. And then I would square both sides. I just erased my work. And my battery. All right, equals 16. And I would then subtract 5 from both sides. And x equals 11. Okay. Again, you can plug that back in and double check that it works to find the perimeter of 26, which it should. All right, after that, we just have one more. It was distance, and I just wanted to remind you of the distance formula. Okay. I'm not going to actually solve this one. I'll let you guys do it, and you can check your answers with me. But the distance formula, y2 minus y1 squared plus x2 minus x1 squared. Okay, that is the distance formula, and all you need to make sure you do is label these correctly. This is x1, y1, and x2, y2. Okay. It doesn't really matter if you switch like this entire thing. Oh, sorry. I'm going to do this. This is not going to really make sense. Actually, I can't do it. Okay. Meaning if I decide this is x2 and y2 and this is x1 and y1, that's fine. Okay. Put that back. What matters is you can't end up mixing. Like these are not both x and these are not both y, and this is not like x1 and y2. Okay. So x1, y1. x2, y2, you just plug the numbers into the formula and solve, okay? Biggest mistakes are adding and subtracting positives and negatives, and a lot of times people forget their square root, so just be careful about that as you think about the test. Okay, again, hopefully it's helpful, and we got one more for chapter 11 going over some of those.